Hi everyone, in this video I'm going to solve Cambridge International AS and A-Level Mathematics Paper 3 Pure Mathematics 3 in a session October-November 2025 Paper 3-1. So let's start with the first question. Question number 1, find the exact value of this integral. Give your answer in the form of a plus natural log of b, where a and b are integers. Okay, so we have to find the integration of natural log of 3x dx. Okay, so as we know that the integration of natural log of x dx does not exist. Now, how do we integrate natural log? Here we apply by parts, right? Integration by parts. Since the integration of natural log is not possible, so we apply integration by parts. We have from 1 to 2, we have the function natural log of 3x. The function is natural log of 3x, its product with 1 and dx. Now we consider natural log of 3x as a first function and 1 as a second function. Okay. Now in integration by parts, we have to take the first function as it is, natural log of 3x, integration from 1 to 2 of the second function 1 dx, minus whole integration from 1 to 2 derivative of the first function and integration of the second function 1 dx with respect to dx. So this dx I put for this integral from 1 to 2. Okay, so integration of natural log is not possible, so we have to apply integration by parts. Take natural log as a first function and 1 as a second function. First function is as it is, integration of second function minus whole integration, take the derivative of the first one and integration of the second one. Okay, now let me simplify this. Natural log of 3x is as it is, integration of 1 with respect to x is just x. Okay, and we need to put the limits from 1 to 2 minus whole integration from 1 to 2 derivative of natural log of 3x is 1 over 3x and 3, and the derivative of 3x is just 3, and the integration of 1 with respect to x is x, and the limits we need to put from 1 to 2 with respect to dx. Okay, let me simplify this further. Here we have x, natural log of 3x. We need to substitute the limits from 1 to 2 minus whole integration from 1 to 2. Now here we can cancel x with x, 3 with 3, only 1 is left. 1 dx. Okay, so x, natural log of 3x, 1 to 2 minus 1 integration with respect to x is, integration of 1 with respect to x is x, and the limits we need to put is from 1 to 2. Okay, so let me combine both functions, it is better. Okay, so we have x, natural log of 3x and minus x, and the limits are from 1 to 2. The upper limit is 2, so x, natural log of 3 times 2 minus, the upper limit is 2 minus 2, this is the upper limit, subtract the lower limit is 1, 1 times natural log of 3 times 1 minus 1, so this is 2, natural log of 3 times 2, 6 minus 2, minus here natural log of 3 minus 1. Okay, now we can say 2 natural log of 6 minus 2 minus natural log of 3 plus 1. So this term goes to the power natural log of 6 power 2 minus natural log of 3 minus 2 plus 1 is negative 1. Okay. Natural log of 6 times 6 is 36 minus natural log of 3 minus 1. And now we can say natural log of 36 over 3 minus 1. Apply the rule that natural log of a minus natural log of b is equals to natural log of a by b. This property I'm applying over here, right? Now we have to simplify 3 times 1 is 3, 3 times 2 is 6. So the simplified answer is natural log of 12 minus 1. Now we need to convert this into, we need to find the exact value of this integral in the form of a plus l and b, where a and b are integers, right? So here we can say the integration from 1 to 2 of natural log of 3x dx is minus 1 plus natural log of 12. A plus ln b. A is minus 1, b is 12. Both are integers. Alright. So in this question, we have to apply integration by parts because the integration of natural log is not possible. So we apply integration by parts, take natural log as a first function and 1 as a second function. So integration by parts, take the first function as it is, integration of the second function minus whole integral, derivative of the first function and integral of the second function. So one integration with respect to x is just x. Natural derivative of natural log is possible. D by dx of natural log of x is 1 by x. Okay, so it is 1 by 3x and 3x derivative is 3, and this integration with x is just x, right? 3 is cancelled with 3, x is cancelled with x, just 1 is left again. 1 integration with respect to x is x. Okay, now both the limits are same, so I combine the whole function and then substitute the upper limit minus the lower limit. When you simplify, apply the power property of log. When you have a natural log of b, then you can say natural log of b to the power a. Okay, so I applied this property and then we can get the simplified form for that integral. I hope this is clear now. Question number 2, part A, show that the equation can be written as a quadratic equation in x. Okay, we need to convert the logarithmic equation into the quadratic equation. This is log base 4 2x plus 1. This is 2 times log base 4 3x minus 1. We have to convert this into log base 4. Okay, so as we know that 1 is always equals to log a. Okay, so if I have 2, that is equals to log a and its power is 2, right? Now we need to make the base 4. So how do we do this? So this would be log 4 2x plus 1 equals log 4, apply the power rule, 3x minus 1 to the power 2 minus, how do I write this 2? So this is log base I want to fix as 4 because every one is 4 to the power 2. So the base and this argument of log is same, right? Okay, now we can combine this. Here we can say log base 4 of 2x plus 1, and here we have log base 4 of, let me open this formula, a minus b whole square, that is equals to a square minus 2ab plus b square. Okay, so 3x square is 9x square minus 2 times 3 is 6 times x times minus 1. So minus 6x, 1 square is just 1 minus log base 4. 4 times 4 is 16. Okay, now we apply the log rule, that log a minus log b, this is log a by b on the right hand side. Okay, so this log 4 2x plus 1, this is equals to log 4, this argument divide this one, 9x square minus 6x plus 1 divides 16. Okay, now on both sides we have the log, we can cancel log base 4 on both sides, right? Now here we are left with 2x plus 1 is equals to 9x square minus 6x plus 1 divided by 16. Now we need to cross multiply 16 on the other side. 16 times of 2x plus 1 is equals to 9x square minus 6x plus 1, because we need to convert the logarithmic equation into the quadratic equation and the variable x. Okay, now this look like a quadratic, so let me do this. 16 times 2 is 32, x 16 times 1 is 16, is equals to 9x square minus 6x plus 1. Now shift all the terms to the right side. We have 0 over here, 9x square minus 6x, and shift the x term minus 32x plus 1, and shift the 16 minus 16. Okay, so 0 is equals to 9x squared. Now the x coefficients are minus 32 and minus 6 is minus 38 x, and from 1 minus 16 is minus 15. So this is a quadratic equation in a variable x, the standard form of the quadratic equation. Now for part B, hence solve the equation. Okay, so we need to solve this equation. So as we have already done in part A, that this equation can be written in the quadratic equation like this. Okay, can be written as the quadratic equation 9x square minus 38x minus 15 is equals to 0. So we need to solve that equation, right? Okay, so it's better to apply the quadratic formula. So from quadratic formula, x is equals to minus b plus minus square root b square minus 4ac divides 2a. So a is the coefficient of x square, which is 9, b is the coefficient of x, which is minus 38, and c is the constant term, which is negative 15. Let me plug everything into the formula to get the solution, right? Okay, so now x is equals to negative, the b value is minus 38, plus minus square root b square minus 38 square minus 4, a value is 9 and the c is minus 15, divides 2 times of a, which is 9, and the square root. Okay, let me simplify this further. X is equals to positive 38 plus minus, let me solve the root. So square root of minus 38 square, this negative times negative makes positive, of 4 into 9 into 15 bracket. This is 8 root 31, 8 square root of 31, and 2 times 9 is 18. Okay. Now here we have two values for x. The first one is 38 plus 8 root 31 divides 18. And the second one is x is equals to 38 minus 8 root 31 divides 18. Okay, let me solve both of them one by one. So the first one is 38 plus 8 root 31 divides 18, 4.585. So 4.5, this 8 rounded to 9, 4.59. X is equals to 4.59, and the other solution is this is negative over here, that is negative 0.363. 0.36 with a negative. Okay, so which one is the correct solution? Let me check. So we need to plug the solution into the equation and simplify the answers. Log 4 2x, verify. Okay, now we need to verify. Log 4 2x plus 1 is equals to 2 log 4 3x minus 1. And negative 2 or positive 2? Negative 2. Okay. Now let's verify the first solution. Log 4, 2 times 4.59 plus 1 is equals to 2 times log 4, 3 times 4.59 minus 1 negative 2. Okay. Log, okay, sorry, log base 4 of 2 times 4.59 plus 1. Okay, this is 1.67, and that is equals to, okay, 2 times log base 4 of 3 times 4.59 point, subtract 1, and we have negative 2 outside, 1.67. This is verified. So it means 4.59 is the solution, right? Let me check the second one whether it is a solution or not. So what is the value at? Now verify log 4, 2 times minus 0.36 plus 1 is equals to 2 times log base 4, 3 into negative 0.36 minus 1 negative 2. Log base 4 and 2 into minus 0.36 plus 1. This is negative 0.9, 0.92, 1/8 rounded to 2, right? And the other side is 2 into log 3 times minus 0.36 minus 1 bracket and minus 2, error. Why? Because log of negative number does not exist, so this is not verified it. So the only solution is 4.59, because you can see when you substitute over here, this is 3 times of negative is negative and this is negative, so log of negative number does not exist, so we have no solution from here. So the only solution is 4.59. So after solving the solutions for log equation, it is better to verify that which x value satisfy your equation, right? So there is only one solution. Question number 3, part A. Express this expression in the form of r cos x minus alpha, where r is greater than 0 and alpha is between 0 to 90 degrees. Okay, so we need to express 3 square root of 2 sine of x plus 45 degrees plus cos theta as r cos x minus alpha. So here we have to use the formula of the two formulas we are going to apply here. The first one is sine a plus b and cos a minus b, right? So let me write down these formulas. Sine a plus b is basically equals to sine a cos b plus cos a and sine b. And the other one cos a minus b, which is cos a cos b plus sine a sine b. Let me apply these two formulas over here. So here we have 3 square root of 2, okay, sine x cos 45 degrees plus cos x sine 45 degrees, and plus cos x is as it is. This should be equals to r, Now the next formula is cos A minus B, cos x cos alpha plus sin x sin alpha. Okay. Now let me simplify this further. Cos 45 sin 45, 3 square root of 2. We have sin x. What is cos 45 degrees? My calculator is in the radian mode, right? Let me convert it into degree mode. Now it is in the degree, right? Now cos 45 degree is root 2 by 2, square root of 2 divided by 2 plus cos x. Sin 45 degree is root 2 by 2, square root of 2 divided by 2 and plus cos x, and that is equals to r cos x cos alpha plus sin x sin alpha. We need to solve for r and for alpha. Alpha must be between 0 to 90 degree and r should be positive, right? Okay, so let me distribute 3 inside the bracket, right? So 3 divided by 2, root 2 into root 2 would be root 2 square, that is just 2, and we have sin x. And this 3 divided by 2, this is 3 by 2, root 2 into root 2 is root 2 square, which is 2, and cos x plus cos x. Now you can cancel this 2 with 2, this 2 with this 2. Okay, and that is equals to r cos x cos alpha plus r sin x sin alpha. Okay, now we can say this is just 3 sin x plus 3 cos x plus cos x is equals to r cos x cos alpha plus r sin x sin alpha. Okay, now these are two cos term. 3 plus 1 is 4 cos x, so this is 3 sin x plus 4 times of cos x, and here we have r cos alpha cos x plus r sin alpha sin x. Now we need to compare the coefficient of sin x and the cos x. You will get two equations, right? So comparing coefficients of the first coefficient I would like to compare is sin x. So when we compare the coefficient of sin x, we have 3 over here, and coefficient of sin x is r sin alpha. That is my first equation. Now compare the coefficient of cos x. Cos x coefficient is 4 over here, and cos x coefficient is r cos alpha on the right side. That is my second equation. Now we have two equations and two unknowns, r and alpha. We can easily get their values, right? So first thing, let me say squaring and adding. Yeah, squaring and adding equations 1 and 2. Okay, now let me square the two equations. 3 square plus 4 square would be equals to r sin alpha whole square plus r cos alpha whole square. 3 times 3 is 9, 4 times 4 is 16, which is equals to r square sin square alpha plus r square cos square alpha. Okay, now further simplification. In 16, if we add 9, this is 25, and here we can take r square common. We are left with sin square alpha plus cos square alpha. And here we use identity that cos square theta plus sin square theta is equals to 1. So their sum should be equals to 1. So 25 is equals to r square, and to get the value of r we need to take a square root on both sides. Sorry. square root and the square root, and whenever we do the root on both sides, the answer should be in plus minus, right? Now this square and this square root is cancelled out. Here we are left with r, and root of 25 is plus minus 5. Now the r value is plus minus 5. Now in the question given that r should be greater than 0, this implies the value of r is 5. In the question it is mentioned that the r value should be greater than 0, so that is why we pick the r, which is equals to 5, right? Okay, now again considering these two equations, we can divide equation 1 over equation 2. Dividing equation 1 over equation 2. Okay, let's do the division. We can say 3 divides 4. 3 divided by 4 is equals to r sine alpha divides r cos alpha. R sine alpha divides r cos alpha. Now here we can cancel r with r. We are just left with sine over cos, and we all know that sine theta over cos theta, the ratio of sine and cos is tangent theta. So use this over here. So 3 by 4, that is equals to tangent alpha. Now we need to solve for the value of alpha. This implies alpha should be equals to tangent inverse of 3 by 4, and the alpha value must lies between 0 to 90 degrees, means in the first quadrant, 0 to 90 degrees. Your calculator must be in degrees when you are calculating the value of alpha. My calculator is in degree mode. Now do tangent inverse of 3 by 4, that is equals to 36.86, rounded to 9, 36.9, 36.9 degrees. So from here we got alpha equals to 36.9 degrees. Okay, so we need to simplify. Okay, so we need to convert this into that expression. Okay, so let me rewrite. This implies we can rewrite the question as 2 root 3 sine x plus 45 to square root of 3 sine x plus 45 degrees plus cos x. This is equals to r cos x minus alpha. R value is 5. Yes, r cos x minus alpha is 36.09 degree, 36.9 degrees. So we need to express this is how we have to express that expression. Now for part B, hence solve the equation 3 root 2 sine 3 theta plus 45 degree plus cos 3 theta. Hold on a second, is it 3? Sorry, 3 square root of 2. I messed up here. This is 3 over here and root is 2. 3 square root of 2. So we need to solve the equation 3 square root of 2 sine x is basically 3 theta and 45 degree plus cos x is 3 theta is equals to this, equals to minus 4 from theta equals to 0 to 90 degree. 180 degree means first and the second quadrant. Okay, so we can rewrite this equation as, so here in this equation we can say let x is equals to 3 theta. So when we replace x with 3 theta, we have 3 square root of 2 sine 3 theta plus 45 degrees plus cos of 3 theta, that, sorry, 3 theta, that is equals to 5 cos x is 3 theta minus 36.9 degrees. Now this thing, if we compare this whole thing with the question, now compare with question, we come to know that this whole thing, the left hand side equals to negative 4. So this implies we can say 5 cos of 3 theta minus 36.9 degrees, that is equals to negative 4. Now we need to solve this equation. Okay, now cos of 3 theta minus 36.9 degrees, that is equals to minus 4 over 5. Okay, now cos is negative, right? So we need to check that cos is negative in which quadrant. Now here cos is negative, so if I can draw the coordinate diagram, and we need to check that in the coordinate axis we have in the first quadrant all trigonometric ratios are positive, sine is positive, tangent is positive, and cos is positive. So cos is negative in the second quadrant and in the third quadrant. So we are only finding the values in the second and the third quadrant. So in the second quadrant, what is your angle? Your angle is always equals to 180 degree minus the base angle, and now this is your angle, right? And in the third quadrant your angle is always equals to 180 degree plus the base angle. Okay, so now let me solve for the base angle here. So the base angle is 3 theta minus 36.9 degrees, that is equals to cos inverse of 4 by 5. We have to, whenever we are finding the base angle, we consider the sign positive, not negative. This negative sign only tell us that cos is negative in which quadrant. So cos is positive in first and fourth and negative in second and third quadrant. Okay, now let me figure out the answer in degrees, right? My calculator is in degrees. Now do cos inverse of 4 by 5. 36.86, 36.9 degrees we can say. Okay, or up to 2 decimal place we can say 36.87. 3 theta minus 36.9 degrees, this is equals to 36.87 degrees. Okay, that is your base angle. Now we can say cos is negative in second quadrant. Let me solve for theta for the second quadrant. So for the second quadrant we have done that your angle is 180 minus the base angle. This is your base angle, right? BA, the base angle. So here we can do your my angle is 3 theta minus 36.9 degrees. So throughout the question you can see this is your angle theta, 3 theta, sorry, this is my angle theta. This is equals to 180 degree minus your base angle, which is 36.87 degrees. Okay, and what is 3 theta, which is, let me solve this side first. Okay, from this 180 subtract your answer, which is 143.13, and shift this term on the other side, becomes positive 36.90, and your theta would be equals to divide by 3 at the end. Okay, sorry. So in this we add 36.9, which is 180.0, and divided by 3. So theta would be divided by 3, 60.0. This is the first value of theta, which is between 0 to 360 degree. 0 to 180 degree, sorry. Okay, now cos is also negative in the third quadrant, as we have done this. Okay, let me find the value for cos. So cos is negative in third quadrant as well. Okay, now for the third quadrant, your angle 3 theta minus 36.9 degrees would be equals to 180 plus that angle, right? Okay, 3 theta minus 36.9 degrees is equals to 180 degree plus 36.87 degrees. Okay, 180 plus 36.87. that is 216.87, 216.87, and shift this term on the other side becomes positive 36.9. This is your 3 theta. Okay, let me add 36.9, 253.77, 253.77, and to solve for theta, divide both sides by 3, divided by 3, that is 84.59, 84.6. Theta is 84.6 degrees. This solution is also in the range 0 to 180 degree. So these are the two desired value for theta, which satisfies this equation from 0 to 180 degree. Question number 4. The diagram shows the graph of this function for x is between 0 to pi by 4 and its maximum point m. So m is basically the maximum point. Okay, find the x coordinate of m. So x coordinate of the maximum point we need to solve basically. What is this x coordinate? We need to figure out. Okay, as we know, for maximum point we need to take the first derivative equals to 0. So first differentiate the function. Differentiate with respect to x. Okay, now dy over dx, that is equals to, do the product rule over here. The first function e powered sine 2x is as it is, d by dx of the second function plus the second function is as it is, d by dx of the first function, the product rule, right? Okay, now dy over dx becomes e powered sine 2x as it is. The derivative of cos is minus sine 4x, and the derivative of 4x is just 4, plus cos 4x is as it is. The derivative of exponential is e powered sine 2x, d by dx of sine 2x. Okay, let's do one more step. Dy over dx, this is equals to negative 4 sine 4x into e powered sine 2x, positive cos 4x. This is e power sine 2x is as it is, and the derivative of sine is cos 2x, and the derivative of 2x is 2. Okay. Further simplification, dy over dx becomes minus 4 sine 4x into e to the power sine 2x plus 2 cos 4x cos 2x e to the power sine 2x. Simplified further, we can take sine 2x common, exponential common basically. Okay, e to the power sine 2x is in both terms. So let me take it common, and we have minus 4 sine 4x plus 2 cos 2x and cos 4x. This is left. This is common and this is common, right? Now we need to solve for the x coordinate of m, and m is a maximum point, and for maximum point, for maximum point we need to put the first derivative equals to 0. Dy over dx should be equals to 0, and we have to solve for x, right? Okay, so e power sine 2x and product with minus 4 sine 4x plus 2 cos 2x cos 4x, this is equals to 0, right? So the exponential never be equals to 0. This implies e to the power sine 2x is never be equals to 0, but minus 4 sine 4x plus 2 cos 2x cos 4x, that should be equals to 0. Okay. Now here let me open the formula for sine 4x and cos 4x. Okay. Sine 2x is 2 sine x cos x, right? So what is sine 4x? Sine 4x would be, it means x is multiplied by 2. So 2 sine 2x and cos 2x. And cos 2x is 1 minus 2 sine square x. And if you do cos 4x, cos of 4x, that is should be equals to 1 minus 2 sine square x is replaced with 2x. Now let me substitute the formula over here. Here we can say negative 4 sine 4x is 2 times sine 2x cos 2x plus 2 times of cos 2x. Cos 4x is 1 minus 2 sine square of 2x, that is equals to 0. So in both terms, if we can simplify, we have minus 8 sine 2x cos 2x plus 2 cos 2x product with 1 minus 2 times 2 4 cos 2x sine square of 2x. Okay, so all these three terms cos 2x is common. So let me take cos of 2x common. Cos 2x is common, minus 8 sine 2x is left, plus 1 is left, negative 4 sine square. Sorry, not 1 is left, 2 is left here because I only took cos 2x common, right? 2 is left here and sine square 2x, that is equals to 0, right? So this implies cos of 2x is equals to 0, or we can say minus 4 sine square 2x minus 8 sine 2x and plus 2 is equals to 0. So from here we can take negative 2 common. So 2 times 2 is 4 sine square 2x, 2 times 4 is 8 sine 2x, and 2 times 1 is 2 is equals to 0. Now this minus 2 divides on the other side, it becomes 0. So 2 sine square 2x plus 4 sine 2x plus 1, that is equals to 0, right? Now cos of 2x is equals to 0. We can solve for 2x, which is equals to cos inverse of 0. That should be the x value is in the range from 0 to pi by 4. Okay, it is in radians. Your calculator should be in the radian mode. My calculator is in degree. Let me convert it into radians. Now this is in the radian mode. Now cos inverse of 0 is pi by 2. So 2x is equals to pi by 2. So what x is? X is equals to pi by 4. Is it possible that the maximum value of x coordinate of the maximum value is pi by 4? It is not possible. So this point gives you pi by 4. M coordinate is not pi by 4. It should be less than m. Right. So here we can say not possible. Okay, this is not possible. The reason is because pi by 4 is not the maximum point, maximum x coordinate for the graph. Okay, now proceed with this equation only. Now this look like a quadratic equation, you guys can see. So let me solve this equation by using a quadratic formula. So here we can say sine of 2x. We can apply the quadratic formula on sine 2x minus b plus minus square root b square minus 4ac divides 2a and the square root. Okay, so what is a, b and c? A is a coefficient of sine square 2x, b is a coefficient of sine 2x, and c is a constant term which is 1. Okay, so if I can proceed this further, so here we have sine 2x. This is negative, b value is 4 plus minus square root b square means 4 square minus 4 a and c divides 2 times of the a value which is 2. Okay. Now if we simplify the term inside the square root, which is 4 square and minus, sorry, it's negative 4 times 2, 8, which is 2 root 2. So here sine 2x is minus 4 plus minus 2 square root of 2 divides 2 times 2 is 4. Okay, further simplification, sine of 2x is equals to minus 1 plus minus root 2 divided by 2. So what I did over here, 4 by 4 is 1, 2 by 4 is 1 by 2, right? This is your solution. Right now we have two cases. We are considering the two cases over here. The first case is sine 2x is equals to minus 1 plus root 2 by 2, and the other case is sine 2x is minus 1 minus root 2 by 2. Okay, now let me solve for 2x. 2x is sine inverse of minus 1 plus square root of 2 by 2. Okay, so minus 1 plus bracket root 2 divided by 2. This is negative of something, right? So this tells us that sine is negative. All right. Hold on a second. I double checked, and when we took a negative 2 common, this becomes positive, this becomes positive, and this becomes negative. Negative 1, right? So minus 1 and minus 1. So from here, the C value is negative 1. The C is negative 1. This negative times negative gives you positive. Okay, now we can say under the radical sign 4 times 4 is 16 and plus 2 times 4 is 8, so 2 root 6. So that is equals to 2 square root of 6. Okay, and this is with root 6. Okay, 4 by 4 is 1, 2 by 4 is 1 by 2, and root 6. Okay, now we can simplify. This is with 6, and we have 6 over here. The green one. Okay. Now we need to simplify what is minus 1 plus root 6, sorry, root 6 divided by 2. This is a positive number, right? Minus 1, your sign is positive. Sine inverse of minus 1 plus root 6 by 2. Sine inverse of answer in radians is 0.2266. Okay, so 2x is 0.2266. Okay, and to solve for x, you have to divide it by 2, which is 0.1133. So x is equals to 0.2266 divided by 3. Right. 0.2266, this is going to divide by 2, so you will get x is equals to 0.1133. This is my x value, the x coordinate of the maximum point. Now let me check the second one. Here sine of 2x is equals to negative of this, so let me check what is minus 1 and minus root 6 divided by 2. That is negative 2.2. Negative 2.2. Here we have no solution. Why we have no solution? Because range of sine theta value must lies between negative 1 and positive 1. So this value is negative 2.22. So this is not in the range. So we have no solution from here. So the only value of x, the only x coordinate for the maximum point is 0.1133. This is the x coordinate of the maximum point. I hope this is clear now. Question number 5. The shaded region on the Argand's diagram shows points represented representing complex numbers z defined by two inequalities. Okay. Now the shaded region, this is a shaded region on this Argand's diagram, shows the point representing complex numbers z defined by two inequalities. The shaded region is bounded by the circle and the line parallel to the imaginary axis. By the circle and the line which is parallel to the imaginary axis, this is your real axis and this is my imaginary axis, right? Okay. The boundaries of the region are included in the shaded region. You can see this boundary and this boundary both are included in the shaded region. Part A, find the two inequalities in terms of z that defines the shaded region. The two inequalities we need to figure out which defines the shaded region. Okay. Now the first inequality is when we are in the considering the normal coordinate system, the xy in the real world, which this is basically x is equals to 2, right? So this straight line is x is equals to 2, and now in this case it is real of z is equals to 2. And how, which portion is shaded? When the real value of z, or when x is equals to 2 is more than, when x is equals to and more than 2, or we can say the real of z is equals to or more than 2. So the first inequality is the real of z is greater than equals to 2 when it is 2 and more than 2. Now you guys can understand that this line is x is equals to 2, and in complex number we can say x is basically real of z. So real of z is equals to 2 and more than 2. So that inequality tells you the shaded region. So this whole thing. But now we have a circle as well. So how do we write the circle in the complex number? So the equation of circle in the complex number is equation of circle in the complex number is absolute of z minus a is equals to r square, right? Where a is a center, a is the center. So what are the coordinates of center? So this is a center, it is mentioned. So the x coordinate and the y, the real is 1 and the imaginary, the real coordinate is 1, the imaginary coordinate is minus 2i. So 1 and minus 2i. Okay, so these are the two coordinates. So we can write the equation of circle as absolute of z minus 1 minus 2i is equals to r square. Okay, so absolute of z minus 1 plus 2i is equals to, what is the radius of this circle? So the radius of the circle is from the center to the point on the circumference. If you are considering from this center to the point on the circumference, from this distance is your radius. You can see 1 unit and 2 units. So the radius is only 2 units, 2 square. This is my radius. Okay. So now the equation of circle in complex number is z minus 1 plus 2 iota is equals to 2 square is 4. Right. Now this is the equation of circle. For this circle, the outer portion is shaded or the inner one is shaded. The inner one is shaded. So we can say less than and equals to this radius. My bad, I did the mistake, because the equation of circle in the complex number is z minus the center equals to the real, the radius, not the radius square. Radius as it is. So the radius is 2, so keep it as it is. In the real, when we are dealing with the real numbers, it is basically radius square, right? So this is only 2. Okay, now the equation of circle is z minus the coordinates of center equals to the radius. The radius is from the center to the point on the circumference. This is your radius, and that is 2 units, front unit and 2 units, so 2 units. So inner portion of circle is shaded, so we can say less than equals to the radius, right? So the second inequality is absolute of z minus 1 plus 2 iota is less than or equals to 2. So these are the two inequalities that defines the shaded region. Let me explain one more time. The first inequality is this value is x is equals to 2, x is equals to 2 and more than 2. So x in the complex number is basically real of z is greater than or equals to 2. And then the equation of circle in the complex number is absolute of z minus the center is equals to the radius. So the coordinates of center is 1 and minus 2 iota. In when we're dealing with the complex number, we are not taking the comma, right? In the real number we write down in comma, but in the complex number we can say z is a complex number, we can write x plus iota y, right? So the x coordinate is 1 and the y coordinate is minus 2 iota. So these are the coordinates of the center, and which we can say a, right? So a value is 1 minus 2 iota minus 1 and becomes plus equals to radius. Radius is from the center to the point on the circumference, from the center to the point on the circumference. This is 1 and 2 units. So radius is just the 2 units. So inner portion of the circle is shaded. So we can say less than and equals to. So these are the two inequalities. I hope this is clear now, which satisfy, which define the shaded region. Now for part B, calculate the least value of argument of z for the points in this region. Okay, so as we know that argument of z is the angle between the positive real axis to whatever your complex number is, right? So in this case, we need to figure out the argument of z, which is the angle between the positive real axis to any of these points in the shaded region, because the points in the shaded region, right? So if I can start from here, let's say this is a positive real axis. So the angle between the positive real axis to any of the points in the shaded region. So we can take this point in the shaded region. This angle is your argument of z, right? Or you can take this point as well. Hold on a second. Yes, this point, or you can take this point, right? But in this case they ask least value. For least means the most negative, the most smallest, the most negative value. So which one is the least one? So the most negative value is this point. That is your argument of z. Okay, so we are not considering rest of it, because they said the most negative value we are dealing with. So let me erase the rest of the points. So now argument of z is the angle between the positive real axis and the least value, means the most negative value. This angle is your argument of z. Okay, so we need to figure out this angle. So we can say this angle is your angle theta. This is my angle theta. Okay, so if we consider this as a right angle triangle, so if I can connect these two, now this look like a right angle triangle, right? So if for this right angle triangle, we can find the angle by using primary trigonometric ratios, by using cos, sine, tangent, right? So we know this side, the base of the right angle triangle is from 0 to 1 and 1 to 2. So this length is 2 units. This length is 2 units, but we don't know about this length. We don't know about this length, means this angle front side is opposite, this side is adjacent, and this is hypotenuse. So means we have we know the adjacent side for this right angle triangle. Now let me figure out this side or this side. This is up to you, right? Okay, now this question is about the complex number. So let me consider this is as a real axis and figure out what are the coordinates for this point. So as we know, this coordinate is 2, but we don't know about the y coordinate for this point, right? So let me consider the normal coordinate axis in the real world. Um, The equation of circle intersect at x is equals to 2. Okay, in real x's, we have the equation of circle, which is x minus a whole square plus y minus b whole square equals to radius square. A and b are the coordinates of center, and we have done the coordinates of center is 1 and minus 2 iota, right? So here the radius is 2, and the center, the coordinates of center a and b are 1 and minus 2. Okay, so here we have the equation x minus 1 whole square plus y minus, and this minus 2 becomes plus 2 whole square. The radius is 2 square, that is equals to 4. Now this is equation of circle in the real world, right? This is equation of circle when we are dealing with the normal coordinate system. Now what is the y value when the x is equals to 2? Because at x is equals to 2, because the point x is equals to 2, it touch the circle, right? Okay, so we can say at x is equals to 2, we can say 2 minus 1 whole square plus y plus 2 whole square equals to 4. 2 minus 1 is 1 square plus y plus 2 whole square equals to 4. So here y plus 2 whole square, 1 square is 1, which is 4, and shift the 1 on the other side, minus 1, that is equals to 3, right? We need to solve for y. So y plus 2 whole square is equals to 3. Now we need to take a square root on both sides to solve for y, and whenever we do the square root, the answer is in plus minus, right? Now this square and this square root is cancelled out. We have y plus 2 is equals to plus minus root of 3, and the y value is minus 2 plus minus square root of 3. Okay, so which y value we are going to consider? Y is equals to minus 2 plus root 3, or y is equals to minus 2 minus root 3. We have two values for y. As we know that the least value, we need to pick the least y coordinate. So this one is the least value. This is not the least one. So this y coordinate I'm going to consider. Now here my x and the y coordinate, the x coordinate is 2 and the y coordinate is minus 2 and minus square root of 3. And when we are doing in the real world, z would be equals to x plus iota y. In the complex world, this is in 2 minus 2 plus root 3 iota. This is my complex. Now these are the coordinates over here. Okay, now here we have done with this coordinate as well. Okay, now we need to figure out this angle. For right angle triangle, the front side is your opposite and this side is your adjacent. So adjacent side is 2, and we need to figure out the length of this side. So what is the length of this side? So the length of this side is, so this length is from 0 to this point, which is minus 2 and minus root 3. So this length is basically 2 plus square root of 3, right? From 0 till minus 2 minus root 3. So the distance between 2 points is 2 plus 2 and plus root 3, right? Now we have the hypotenuse as well, right? Okay, now we can use a ratio for opposite over the hypotenuse, a ratio of tangent. So here we can say tangent theta is opposite over the adjacent, sorry. So the opposite side is 2 plus square root of 3 and the adjacent side is 2. So to solve for theta, we can do tangent inverse of 2 plus square root of 3 divided by 2. You can do the angle in degrees or in radians. This is up to you. Okay, and one more thing. As this angle is between the positive real axis to the point, so this is to the point in your shaded region, so this angle is in clockwise direction. So the clockwise angle is always negative. Clockwise angle is always negative, right? So we have to consider it negative, right? So this theta is basically negative of tangent inverse of 2 plus square root of 3 divided by 2. You can do in degrees or in radians, both are correct. Okay, Okay, now my calculator is in the radian mode. We can do in radians first, right? So do tangent inverse of 2 plus square root of 3 divided by 2 and the bracket. So this angle is 1.08. Theta is minus 1.08 radians, or we can also do in degrees. So theta is negative of what degrees? If I convert my calculator into degree mode and figure out the answer in degrees, 61.8 degrees. 61.8 degrees. So this is answer in degrees, right? So these are basically the argument of z. Okay, these are the argument of z is minus 1.08 radians or negative 61.8 degrees, right? Why negative? The negative is because this angle is in clockwise direction. Clockwise direction angle is always negative. Question number 6, solve the quadratic equation. This is w square w and constant equals to 0. Give your answer in the form of x plus iota y, where x and y are real. We need to give the answer in this form. Okay. So now this is a quadratic equation. 2 plus I w square plus 4w plus 2 minus I, this should be equals to 0. We can solve this quadratic equation by using quadratic formula. W equals to minus b plus minus square root b square minus 4ac divides 2 times of a, okay, where a is a coefficient of w square, which is 2 plus iota, b is a coefficient of w, which is 4, and c is a constant term, which is 2 minus iota. Okay, now let me substitute everything into the quadratic formula. So w is equals to negative b value is 4 plus minus square root b square means 4 square minus 4a is 2 plus iota and c value is 2 minus iota. Square root and everything divides by 2 times of the a value, 2 plus I. Okay, now here we use a difference of square formula, a plus b into a minus b, that is equals to a square minus b square, right? So this is a 2 plus I, 2 minus I, 2 square minus I square. W is equals to minus 4 plus minus square root 4 times 4 is 16 minus 4, we have 2 square minus I square. Everything divides by 2 times 2, 4 plus 2 iota. Okay, now w is equals to negative 4 plus minus square root 16 minus 4 in the bracket. 2 times 2 is 4 minus iota square, and we know that iota square is always equals to negative 1. This is a standard value for iota square, right? This thing divides 4 plus 2 iota. So w is equals to minus 4 plus minus square root 16 minus 4 into 4 minus is plus 1, because iota square is minus 1, this minus 1 and this minus 1 becomes plus 1, right? And divided by 4 plus 2 iota. Okay, so let me simplify the term under the square root sign, which is square root 16 minus 4 bracket 4 plus 5 1 is 5. Wait, let me do it manually because this will gives me in iota. So w is equals to minus 4 plus minus square root 16 minus 4 times 5 is 20 divides 4 plus 2 iota. So here we have minus 4 plus minus square root from 16, take a 20 minus 16, we have negative 4 divides 4 plus 2 iota. As we know that square root of minus 1 is equals to iota, right? So we can rewrite this as w is equals to minus 4 plus minus square root 4 into square root of minus 1 divides 4 plus 2 iota, right? So this is minus 4 plus minus square root of minus 4 is 2 and root of minus 1 is iota divides 4 plus 2 iota. Okay, now we have two solutions here for w, right? The first solution is w is equals to minus 4 plus 2 iota divides 4 plus 2 iota, and the second solution for w is minus 4 minus 2 iota divides 4 plus 2 iota. Okay, now these are the two solutions for w, but we need to convert it into the form of x plus iota y, which whenever we have iota in the denominator, we have to rationalize it, right? So rationalization means multiplying and divide by the conjugate of the denominator. So the denominator conjugate is 4 minus 2i, 4 minus 2i, and here 4 minus 2i, and here also 4 minus 2i, multiplying and dividing by its conjugate, right? Now simplify. This is 4 times 4 minus 16, 4 times 2 minus 4 times minus 2 plus 8i, 2 times 4 8 plus 8i, 2 times 2 4 minus 4 I square, and the denominator 4 plus 2i, 4 minus 2i, which is 4 square minus 2i square. Further simplification, w would be 8 plus 8 is 16 minus 16 minus 4 iota square is negative 1. 4 times 4 is 16, sorry, 8 plus 8 16i minus 16 minus 4 and iota square minus 1. 4 times 4 is 16 minus 2 times 2 is 4, iota square is minus 1. Okay, further simplification, w would be equals to 16i minus 16 and plus 4 divides 16 plus 4. So w would be equals to, from 16 take away 4 is negative 12 and plus 16i, and here we have divide by 20. Now w here is minus 20, 12 by 20 plus 16 over 20 I. So w would be, we can say 4 times 3 is 12, 4 times 5 is 20, 4 times 4 is 16, 4 times 5 is 20 iota. Now this w is in the form x plus iota y. This w is in the form of x plus iota y. So this is the first solution for w. Okay, now let me do the second one. By rationalization, w would be equals to minus 4 times minus 4. This becomes 16 minus 16. 4 times 2 8 plus 8 iota. This is with minus 4 times 2 8 minus 8 iota. Okay, and here we have minus 2 times minus 2 is plus 4 iota square, and in the denominator we have 4 plus 2i, 4 minus 2i means 4 square minus 2i square, minus 16. This positive negative is cancelled out, plus 4 iota square is minus 1. 4 times 4 is 16 minus 2 times 2 is 4 iota square. W is equals to minus 16 and minus 4. Divide 16 minus 4 iota square is negative 1. So w is negative of 20, because minus 16 minus 4 is minus 20 in the numerator, and the denominator we have 16. Negative times negative is positive 4. So w is equals to negative 20 divided by 20. So here the w value is negative 1. So we need to write this w into x plus iota y. So this is w is equals to minus 1 plus 0 iota. This is a second solution for w. So these are the two solutions for w. You need to find the answers in the form x plus iota y, where x and y are real. So you can see this x and y both are the real numbers. Question number 7. The parametric equations of a curve are x is in terms of t and y is in terms of t. Obtain a simplified expression for dy by dx in terms of t. Okay. So basically we have to apply chain rule. First differentiate the x with respect to t, then differentiate y with respect to t, then we apply the chain rule to get dy over dx, right? So we have the function x, which is x is equals to t square minus natural log of 2t plus 1. Okay. Now we have to differentiate this function with respect to t. So we can say differentiate with respect to t. Okay. So let me do differentiation. Dx over dt means d by dt of this x. The derivative of t square is 2t minus natural log of t derivative is 1 over that function 2t plus 1, and the derivative of 2t plus 1 is just 2. Okay. So the simplified expression for dx over dt, that is equals to 2 times t minus 2 over 2t plus 1. Okay. Let me simplify this further by taking the LCM. 2t is multiply with this denominator 2t plus 1, and minus 2 is as it is, whole divides 2t plus 1. So that is 2t times 2t, 2 times 2 is 4, t times t is t square plus 2t minus 2 divides 2t plus 1. So this is expression for dx over dt, right? Okay. Now this implies, let me write down dx over dt. That expression is 4t square plus 2t minus 2 divides 2t plus 1. Okay. Now let me take the function y, which is t over 2t plus 1. Okay. So y is equals to t over 2t plus 1. Is it plus 1? Yeah, it's plus 1. Now here we have to differentiate with respect to t. Differentiate with respect to t on both sides, right? So let's start differentiation. Dy over dt. Okay, now here you can see the numerator, the function is t, denominator is a function of t. So we have to apply the quotient rule over here. The denominator function is as it is, derivative of the numerator function, t derivative with respect to t is 1, minus the numerator function, and the derivative of the denominator function 2t plus 1 derivative is just 2, divides the denominator function square. Okay, so this is 2t plus 1 minus 2t divides 2t plus 1, product with 1 is 2t plus 1, minus 2 times t is minus 2t. So 2t plus 1 whole square. Plus 2t and minus 2t is cancelled out, 1 over 2t plus 1 whole square. So this is a simplified expression for dy over dt. So here we can say dy over dt we got is 1 over 2t plus 1 whole square. Okay, now here we apply the chain rule. So in the chain rule, we can say the derivative of the function y with respect to x, dy over dx is dy over dt multiply dt over dx. Dy over dx, this is dt, right? Okay. Substitute everything. Dy over dx, this would be the derivative of y with respect to t. We have 1 over 2t plus 1 whole square. Okay, now dx over dt. We have dy over dt. So how do we get dx over dt? We have to switch. Sorry, dt over dx. Dt over dx. We do the reciprocal on both sides, right? So the dx over dt reciprocal is dt over dx, and this reciprocal is, we have to flip the fraction, 2t plus 1 now in the numerator, and 4t square plus 2t and minus 2, this becomes the denominator, right? Okay, let me write this down. Multiply 2t plus 1 divides 4t square. We have 4t square, sorry, plus 2t and minus 2, plus 2t and minus 2. Okay, the question is to figure out the simplified expression for dy over dx, right? The simplified expression. Okay, so as you can see, this expression is cancelled out with one of its power, because here we have 2t plus 1 twice, 2t plus 1 into 2t plus 1, so one expression is cancelled out, right? Okay, so what we have left over here, we can say dy over dx. Now this is 1 over 2t plus 1, and its product with 4t square plus 2t minus 2. Okay, now this is in the simplified form, so let me simplify this as well. Dy over dx, say 1 over 2t plus 1 is as it is. Let me take 2 common. We have 2t square plus t minus 1. Okay, now we can factorize this because it is a quadratic equation. We can factorize it. 2 times minus 1 is minus 2. If you can do 2 minus 1, that is equals to 1. So break the midterm, right? So dy over dx, that is equals to 1 over 2 into 2t plus 1. So I shift this 2 before that factor and break this midterm. 2t square is as it is. We can break the plus t into 2t minus 1t plus 2t minus t minus 1, because 2 minus 1 would be just t. Okay, simplify this further. Dy over dx, that is 1 over 2 into 2t plus 1, and here we can take 2 and t common. We have just t is left, sorry, 2t is common, t is left, 2t is common, plus 1 is left. Take negative 1 common, t plus 1 is left. Okay, now dy over dx in the simplified form is 1 over, hold on a second, let me write down the simplified expression for dy by dx in terms of t. The numerator is just 1, so 1 divides 2 into 2t plus 1. 2t minus 1 is the factor, and t plus 1 is the factor. So this is the simplified expression for dy over dx. Okay. Question number 8, the variables x and y satisfy the differential equation. This is the differential equation where k is a constant. It is given that y is 0 when x is 0, y is minus 1 by 2 when x is 1. Solve the differential equation and find the exact value of y when x is equals to square root of 3. So we have given the differential equation and we have given two conditions. To figure out the first two conditions means we must have two unknowns. To figure out that those two unknowns, we have two conditions, right? And then after solving the differential equation, we have to find the exact value of y when the x is square root of 3. So let me write down the differential equation. So this is a separable differential equation. You guys can see the x variable can be separate easily and the y is also separate easily, right? So this is a separable differential equation. Separable differential equation In separable differential equation, we can easily separate the x and y, right? So let's see, can we easily do the separation? So x square plus 1, its product with dy over dx, and that is equals to k. We have x and e power 2y. So this is a function of x, this is a function of y, this is x, this is y, this is x. Okay, so let me try to separate it. Dy is already over here. Okay, so let me shift all the functions on the other side, right? So k is a constant, x, and we can divide by x square plus 1 and dx, and here we can say 1 over e power 2y. So what I did, let me explain you. Dy is already on the left side. I just shift divide both sides by e power 2y. So I shifted so I combine the y terms, the variable y on the left. Now let me separate the variable x on the right side. Now kx is already on the right. I divide this on the other side and multiply it by dx. Now you can see dx terms are on the right side, dy are on the left side. So x and y, both the variables are easily separate, right? So we have a separable differential equation. Here we can say e power minus 2y dy is equals to k is a constant, x over x square plus 1 dx. For when you have a separable differential equation, you have to do integration on both sides, right? So let me take integral on both sides, integration of this side and the integration of this side. Now we have two conditions. One condition used to solve for k and one condition is used to solve for the constant of integration. That is why they gave us the two conditions. Okay, now we know that the integration of e power x, integration e power x dx is always equals to e power x plus some constant of integration, right? Okay, so e power minus 2y, integration is e power minus 2y with respect to y, but the derivative of minus 2y is negative 2, so you have to divide into the numerator plus the constant of integration, so the denominator, that is equals to k is a constant. Okay, now here we can say the integration of 1 over x dx is basically equals to natural log of x plus some constant of integration. 1 over x integration is natural log of x when the derivative of x is 1, which is complete in the numerator. So what is the derivative of x square plus 1, which is 2x? So we have to complete that derivative. So means you have to divide by 2 and multiply by 2. Now you can see 2x is the derivative of the denominator function. It is completed in the numerator. We can easily apply natural log, right? Now this is k divided by 2. Here we have natural log of x square plus 1 plus the constant of integration. Now we have to combine constant of integration, right? So combine constant of integration. Okay, so once we combine the constant of integration, here we have e power minus 2y divided minus 2 is equals to k divided by 2 natural log of x square plus 1 plus the constant of integration. You can write constant of integration just once, right, after completing the whole integration, right? Okay, now this is a simplified form. Now we have two conditions. One condition is to solve for k, the other condition is to solve for c. Two conditions, two unknowns, right? So let me use those two conditions and solve for the unknowns. The first condition is when x, y is 0, x is 0, right? So we have given that x is equals to 0, y is equals to 0. So let me use this condition. E power negative 2 times 0 is 0, divides minus 2 is equals to k by 2. Natural log x is 0, we have 1 plus c. Okay, e power 0 is 1, so it is 1 over negative 2 equals k over 2. Natural log of 1 is 0 plus c. So this whole thing is 0. So negative 1 by 2 is equals to, this whole thing is 0, so we have left with c. It means we got the c value, which is equals to negative 1 by 2. Okay, now let me substitute the c value over here, which is negative 1 by 2. Use a second condition: when x is equals to 1, y is minus 1 by 2. Okay, so given that x is equals to 1, y value is negative 1 by 2. Okay, so let me substitute this condition: e power minus 2y. Okay, so minus 2 and the y is minus 1 by 2 divides negative 2 is equals to k by 2 natural log of x square plus 1. Natural log of 1 square is 1 plus 1 plus the c value, which is negative 1 by 2. It's negative over here, so it's minus 1 by 2, right? Okay, so now this is negative 2, this is negative 2, this is cancelled out. This is e power 1 divides negative 2, and that is equals to k by 2 natural log of 2 minus 1 by 2. Okay, so we can take 2 common on both sides, or let me solve for k basically. So we have negative e over 2 positive 1 by 2, that is equals to k natural log of 2 divided by 2. Okay, now let me take 2 common from here. E plus 1 divides 2 is equals to k natural log of 2 divides 2. So you can cancel the 2 on both sides, and here we are left with negative e plus 1 is equals to k natural log of 2. And to solve for k, we have to divide natural log of 2 on the other side. So from here we got the k value, which is 1 minus e divides natural log of 2. So this is for k. Okay, now we have k and we have c. We can write, substitute into the differential equation, static, right? Okay, so we can say put k and c value in equation static. Okay, now the equation static is e power minus 2y divided by negative 2. E power minus 2y divides negative 2 is equals to k. K value is 1 minus e divided natural log of 2, k by 2. So 1 by 2, and its product with the natural log of x square plus 1. So multiply natural log of x square plus 1 plus the c value, which is minus 1 by 2, right? So this is the equation. Now the question is, find the solve the differential equation. We have solved that differential equation. Now we need to find the exact value of y when x is square root of 3. Okay, so the exact value of y when x value is square root of 3. Again, 2 is common on both sides. So here we can say minus 1 by 2 e power minus 2y, and we can take 1 by 2 common. 1 minus e over natural log of 2 into natural log of x square plus 1 and negative 1. Okay, so cancel 1 by 2 and cancel 1 by 2 on both sides. We are left with negative e power minus 2y is equals to 1 minus e over natural log of 2 and its product with natural log of x square plus 1 negative 1. We need to solve y in terms of x when x is equals to square root of 3. Okay, so it is better to solve for y. So here we can say at x is equals to square root of 3. So let me put x as square root of 3. Negative e power minus 2y is equals to 1 minus e over natural log of 2. Its product with natural log square root of 3 whole square plus 1 negative 1. Okay, So this is minus e power minus 2y is equals to 1 minus e divides natural log of 2 and its product with natural log. This is cancelled out. 3 plus 1 is 4 minus 1. Okay, let me simplify this further. Minus e power minus 2y is equals to 1 minus e over natural log of 2 and its product with natural log 4 is 2 times 2 minus 1. Okay, let me simplify this further. So we are not supposed to, because 4 is 2 times 2, right? So 2 square is 4. Minus e power minus 2y is equals to 1 minus e over natural log of 2 and natural log 2 square is 4 and minus 1. Apply the log property minus e. Okay, 1 minus e over ln 2 is as it is. 2 times natural log of 2. So we have to apply natural log a power b is b times natural log of a, the power rule for the logarithm, right? And this minus 1 is as it is. Now this, sorry, negative 1 is as it is. Now we can cancel natural log of 2 with natural log of 2, right? And we are left with minus e power minus 2y is equals to 2 times 1 minus e and negative 1. Okay, now minus e power minus 2y is equals to 2 minus 2 times e minus 1. So here we have minus 2 times e and plus 1, because 2 take away 1 is just plus 1. And here we have minus e power minus 2y. Now let me take a negative sign common, e power minus 2y and the negative sign common, so 2e minus 1, and cancel the negative sign on both sides because I took the negative sign common from both sides, right? And here we are left with e power minus 2y is equals to 2e minus 1. Now we have to take ln on both sides. So we can say taking natural log on both sides, because we have to solve for y, right? Okay, so when we apply the natural log e power minus 2y is equals to natural log 2e minus 1. So applying the log property, minus 2y comes before the natural log of e, natural log of 2e minus 1. We all know that natural log of e is always equals to 1. So we can name it as 1 and simplify further. Minus 2y is equals to natural log of 2e minus 1, because this whole thing natural log of e is 1. Okay, and y would be equals to negative 1 by 2 natural log 2e minus 1. I divide minus 1 by 2 on the other side. So this is the exact form of y is minus 1 by 2 natural log of 2e minus 1. Yes. So this is the exact solution. Y in terms of x when x is square root of 3. That is a final answer. Question number 9, part A. By sketching a suitable pair of graphs, show that the equation has only one real root in the interval 0 to pi by 2. Okay, so we need to sketch the graph secant 2x equals to negative e power x. Okay, so before sketching it on both of the function on one graph, it is better to explain you guys how do I sketch it separately. So secant is basically a reciprocal of cos, right? So we can say y equals to cos x. Let me sketch the graph of y equals to cos x and show you guys. Okay, so if I take the graph of y equals to cos x, right, let's say this is 1, here we have a point 0 and here we have a point negative 1. Okay, so the graph of cos, it is between 1 and minus 1. 1 is the maximum and minus 1 is the minimum. So this is the one complete cycle for the graph of the cos function. So one complete cycle starts from 0 to 2 pi, because we know that the period of cos function is 2 pi. Period is basically one complete cycle from one maximum to another maximum, right? So cos of 0 is 1 and this value is pi by 2 and this is pi, and this pi by 2 to 3 pi by 2, and then 2 pi. This is a one complete cycle for the cos, right? But we need cos 2x, right? So the second thing is y equals to cos of 2x. So what happened? We have a stretch in x direction by a scale factor of 1 by 2. So this is basically a stretch in x direction by a scale factor of the reciprocal of 2, 1 by 2, means all the x coordinates and product by 2, right? Divide by 2, right? Okay, so let me sketch this graph again. Wait a second. Okay, let's say this is again the 1, we have 0, we have minus 1, right? Now we have a stretch in x direction by a scale factor of 1 by 2, right? So when we have a stretch in x direction by a scale factor of 1 by 2, it means x coordinates multiplied by 1 by 2. We need to multiply the x coordinates by 1 by 2. So this is 0. 0 is multiplied by 1 by 2 or divide by 2. Basically 0 by 2 is still the same, stays the same, which is 0. So we have the same point 1. Now we have a pi by 2. Pi by 2, it's divide by 2. So it's pi by 4. And this is your pi by 2. We have the same sketch. Okay, now 0 by 2, pi by 2 divides by 2 would be equals to pi by 4. Pi multiply 1 by 2 is, this is your pi by 2. This is your 3 pi by 4 and pi by 2, and here we have a pi. Okay. Now cos 2x, this is a graph of cos 2x, and the domain we have given is from 0 to pi by 2. So 0 to pi by 2 means till this point. This is the 0 and this is pi by 2. So this is the whole domain for x. X is from 0, is x is less than pi by 2. So this value only we're going to treat, right? So if I can say y is equals to cos of 2x at x is between 0 to pi by 2, so what would be the graph? Let me plot it once more. Okay, so this is from, this is how the sketch look like: 1 0 minus 1, right? This point is your pi by 4 and this point is your pi by 2, means 0 and pi by 2 both are not included. This is a graph of y equals to cos 2x. I hope you are getting me. Now we have to do the reciprocal, because secant is a reciprocal of cos. The reciprocal of cos x is basically secant x, right? So basically we need to do the reciprocal of this graph to get the secant x graph. Now we have y is equals to 1 over cos 2x. You will get secant of 2x. Okay, so we have the point 0, we have the point x is equals to 0, x equals to pi by 4, x equals to pi by 2. We have 3 points basically, right? 0 and pi by 2 both are not included here, right? Pi by 4 is included in the graph of y equals to cos 2x, right? So let me check if we do the reciprocal of pi by 4, since 0 is not included, right? Pi by 2 is not included in the domain. 0 and pi by 2 both are not, the equality is not over here, right? Pi by 4 is included. So if I can say at x is equals to pi by 4, you will get a vertical asymptote. How do we get a vertical asymptote? So if I can put x equals to pi by 4, y is equals to 1 over cos of 2 times of pi by 4. 2 times 1 is 2, 2 times 2 is 4. So this is 1 over cos of pi by 2. Cos pi by 2 is basically cos of 90, which is 1 over 0. That is infinity. So we have a vertical asymptote at x is equals to pi by 4, because it gave us infinity, right? Okay, so we have a vertical asymptote at x is equals to pi by 4. Let me sketch this graph and show you guys. Make it a bigger one. Okay, now let's say this is x is equals to pi by 4. This point is x is equals to pi by 4. Now this is a vertical asymptote, right? When we do secant to x. Okay, now at, you can see at x is equals to 0, its value is 1 and 1 is the maximum point. Now when you do the reciprocal, 1 is going to be the minimum point. If you have 1 here and you have minus 1 over here, so 1 is the minimum point. This is how your graph look like. Okay, now pi by 2 is your minimum here. Now pi by 2 is going to be the maximum point on the other side. Let's say we have a pi by 2 over here. This pi by 2 is your maximum point and it is going down. Okay, this is how the sketch of y is equals to secant of 2x look like, right? First thing, you have to figure out the vertical asymptote. 1 was before the maximum point, now 1 is going to be the minimum point, right? And this pi by 4 2, at pi by 2 it is minimum, and now at pi by 2 it is going to be a maximum. It's going down, right? Because we are doing a reciprocal on both sides, right? The reciprocal of down, it's up. The reciprocal of down, it's up, right? Okay, so we have done with the secant part. Now the second one is e power x graph, the exponential graph. Now this is your the first graph, right? Now let me do the graph of y equals to e power x, the graph of exponential function. How do the graph of exponential look like? Okay. Okay, so the graph of exponential e power x has a vertical asymptote x is equals to 1. Sorry, y equals to, sorry, my bad. It has a y-intercept, y equals to 1. This is a graph of e power x. Okay, now when we do the graph of y is equals to negative e power x, it means we have a reflection in x-axis. Yeah, negative e power x. So we do a reflection in x-axis. Okay, so when we do the reflection, this is your x-axis. You can see this is your x-axis, right? So you do the reflection in x-axis, you have to flip the graph. Now one was the vertical y-intercept before. Now minus 1 is your y-intercept when you do the reverse, right? So let me sketch this one as well. Okay, so when I do this on the other side, yes, this is your negative 1. This is minus e power x. Okay, I hope this is clear now, right? Both the graphs are clear. This one is your second graph and this one is the first graph. Now we have to uh, sketch, by sketching a suitable pair of graphs on the same diagram. We have to sketch both of them and we need to show that it has only one real root in that interval. So let's say for this it has interval from 0 to pi by 2 is that interval, because we are just eating from 0 to pi by 2, 0 to pi by 2. Okay, let me combine the two graphs. Now this implies when you do secant of 2x is equals to negative e power x. Okay, let me combine both of the graphs. 1 2 3 4 5 6 7. Okay, now this is 0. Here we have 1, here we have negative 1. Okay, now for secant 2x, the graph upward, then vertical asymptote, and then downward. Okay. it goes up, and at pi by 4 we have a vertical asymptote, and at this is pi by 2. At pi by 2, this is how it look like for the secant one. Let me correct it a bit more. Not exactly. Yeah. Okay. And the exponential graph goes down. Minus 1 is your vertical asymptote. Uh, y-intercept. If I can do with the green one. Okay. Now we can see that the blue graph and the green graph both have only one point of intersection. So they have one point of intersection in the interval from 0 to pi by 2, because we're just doing 0 to pi by 2, not the other part, sorry. So we have to raise this part because we are doing from 0 to pi by 2. So this is how the sketch for the exponential function look like. Okay, so it has only one point of intersection. When it has one point of intersection, it means we have one real root in the interval from 0 to pi by 2. We just need to show with our graph that it has only one real root in that interval, and we have only one real root, you can see. I hope this is clear now. Now for part B, show by calculation that this root lies between 0.9 and 1. We need to show that this root lies between the x value, this is the x, basically the x value between 0.9 and 1. Okay, so it means there must be a sign change. If you can see a sign change between the two values, then we can say a root must lies between them. Okay, so we have the function. Let me make the function f of x is equals to e power minus x and minus secant of 2x. So how do I make the function? This is e minus e power x is as it is. I shift that function on the other side, becomes negative, right? Okay, there must be a sign change. Okay, now what is the function value at 0.9 and what is the function value at 1? Minus e power 0.9 minus sine secant, sorry, 2 times of 0.9 minus e power 1 minus secant 2 times 1. So keep it in mind your x must be in radians, right? Your calculator should be in the radian mode. My calculator is in the degree mode. Let me convert it into radians. Now the calculator is in the radians. Now what is negative exponential 0.9, and then we have a negative secant. Secant is a reciprocal of cos. 1 over cos, 1 divides cos of 2 times 0.9 bracket. 1.94. This is 1.94, and the second value is 1. Okay, this value is going to be 2 times 1, and in the exponential the value is also 1. Negative 0.32. So here we can say, since sign change can be seen between the function value at 0.9 and the function value at 1, hence root lies between 0.9 and 1. So when there is a sign change, the root lies between them. This is positive and this is negative, so it's a sign change, right? Now for part C, show that if a sequence of values given by the iterative formula converges, if this sequence converges, then it converges to the root of equation in part A. Then it must converges to the root of the equation in part A. This is equation in part A. This. It must converges to this, okay? Let's see if it is converges, then it must converges to secant 2x equals to minus e power x. Let's see. Okay, so here we have 1 by 2. So x power x subscript n plus 1. So we have to multiply by 2. On the other side, cross multiply basically, and this is cos inverse of minus e power minus xn. Okay, then 2x n plus 1, we can do cos on the other side. Cos of this should be equals to minus e power minus xn. Okay, all right, so let me do the reciprocal on both sides. 1 over cos 2 times x subscript n plus 1, this is equals to minus 1 over e power minus xn. Reciprocal on both sides. So when we do the reciprocal of both sides, right? Okay. Now 1 over cos is a ratio of secant. 1 over cos, yes, secant of 2 times x subscript n plus 1. This is negative. When you shift this to the numerator, e power positive xn. So you can see this converges to the equation in part A. It is proved that it converges to that equation in part A. So the equation in part A, secant 2x is equals to negative e power x. So it is converges, it is proved. So they said if this sequence of values converges, then it must converges to that equation. So it is proved that it is converges and it converges to that equation. If it converges to that equation, it is proved that this sequence of values converges. Yes, it's true. Now for part D, use the iterative formula given in part C to calculate x correct to 3 decimal place. Give the result of each iteration to 5 decimal place. So what is iterative formula given in part C? So this is part C. This is iterative formula xn plus 1. Xn plus 1 is equals to 1 by 2 cos inverse of 1 by 2 cos inverse of negative e power minus xn. Right. Okay, so as we have done that, this sequence of values converges and it converges to this equation, right? And we have done the roots of this equation, that the root of this equation lies between 0.9 and 1. We have already calculated that root of this equation lies between 0.9 and 1. So it means we have to take the initial guess between 0.9 and 1. Okay, so the initial guess, we can say x naught, we can take 0.95. You can take any number between 0.9 and 1, right? Okay, now let's do the iterations. Let me start doing the iterations. So when n is equals to 0, we have x1, which is 1 by 2 cos inverse of negative e power minus x naught. Okay, up to 5 decimal place, right? Okay, right. 1 by 2 into cos inverse of negative e power minus 0.95. Okay, 0.12345. This is a 5 decimal place. The next digit is 5, so it is round up. So it's going in 4 and add 1, it's become 5. 98395. 0.98395. Okay. Next, when n is equals to 1, we have x2, which is 1 by 2, cos inverse of negative e power minus x1. This is your x1 value, right? Let's see. 0.98395. 8395. Okay, 1, 2, 3, 4, 5 decimal place. The next digit is 6, so it becomes 7. 97697. 0.97697. Okay. N is equals to 2. The next iteration we will get n x3, 2 plus 1, 3, which is 1 by 2, cos inverse negative e power x2, negative, negative of x2, yes. So this is 0.97697. 1, 2, 3, 4, 5 decimal place. This is 7. The next digit is 8. So you have to add 1 in 7, round up. So this is 0.97838. 0.97838. Okay, next iteration we can do n is equals to 3 x4, 1 by 2, cos inverse of minus e power negative x3. This is my x3 value. Okay, x3 value would be 0.97838. 0.9 1 2 3 4 5. This is 5 decimal place. 97809. 0.97809, up to so on. Okay, now we can easily guess what is the value of x. Correct to 3 decimal place. Okay, 0.9898. This turns to 4. 977. 978. So 0.978 is the better estimate. This implies value of x up to 3 decimal place is x is equals to 0.978. That is the better estimate. This is the value of x. I hope this is clear now. Okay. Question number 10. Let f of x is this function. Part A, express f of x in partial fractions. Okay, so we need to express f of x in partial fractions. So keep it in mind that partial fraction is possible only for the proper fraction. Let's see this fraction is a proper fraction or improper. If it is improper, then we have to make it a proper fraction first, and then we can do a partial fraction, right? So let me check this fraction is a proper or improper fraction. So we need to expand the denominator. So the numerator is x cube plus 2x minus 11 divides, if I expand, 3 times 2 is 6, 3 times x square is 3x square, x times 2 is 2x, x times x square is x cube. Now here we have x cube plus 2x minus 11 over x cube plus 3x square plus 2x plus 6. You guys can see the degree of the numerator and the degree of the denominator both are equal. It means the degree here is 3 and the degree here is also 3. So when the degree of the numerator and the degree of the denominator both are equal, right? So degree of numerator is equals to degree of denominator, means 3 is equals to 3, then that is your improper fraction. And when the fraction is improper, what we have to do? We have to make it a proper fraction, because partial fraction applies only on proper fraction. When you have improper fraction, you have to convert it make a proper fraction, and then you can do a partial fraction, right? So partial fraction is only apply on that fraction which is proper. Improper fraction, partial fraction is not applicable, right? So how do we convert proper fraction into improper fraction? So we have to go through a long division method. Long division method is used to convert improper fraction to proper fraction. Convert improper fraction to proper fraction. Okay, so whenever you have a question of partial fraction, the first thing you need to check is the fraction, whether the fraction is proper or improper. The fraction, you have to simplify your numerator, which is already in the simplified form, simplify your denominator. When the degree of numerator and the degree of denominator both are equal, or when the degree of numerator is more than the degree of denominator. Okay, we have when the degree of numerator is greater than the degree of denominator, or when the degree of numerator is equals to the degree of denominator. In both cases we have improper fraction, and for improper fraction, we partial fraction is not applicable. So we have to, for improper fraction, we have to go through a long division method to convert the improper fraction to proper fraction, and then we can do a partial fraction, right? Okay, degree is basically the power of highest polynomial. The power of the highest polynomial is your degree, right? So when the degree is equal, or when the degree of numerator is more than the denominator, then we have improper fraction can be converted into proper fraction by using a long division method. So let me go through the long division method here. So for long division method, we have here, we have two x cube. Okay, it is better to, we have, this is your divisor, right? X cube plus 3x square plus 2x plus 6, that is my divisor. And x cube plus 0x square plus 2x minus 11. Now most of the student will get confused why I'm adding 0x square, because I just simplify the x cube term, then x square term, x and the constant term, so there is no x square term. So that is why I just add 0 times x square, right? Okay, now let me go find out the quotient. So the first term, we have x cube plus 3x square plus 2x plus 6. It is going to multiply by 1 to make x cube plus 3x square plus 2x plus 6, right? And then we can easily cancel x cube because we make x cube. So we have to product with 1 to make x cube, 3x square plus 2x, and then plus 6, right? Now we have to subtract it. In subtraction, we change the sign. Now this sign before was positive, now we have to change the signs: negative, 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 and negative. All right. Okay, now positive x cube and negative x cube, these two are cancelled out, and here we are left with 0x square, and minus 3x square would be minus 3x square. Positive 2x and negative 2x, again this is cancelled out, and here we are left with minus 11 and minus 6 would be negative 17. Okay, we cannot do a further division. You can see here we have x cube and here we have x square, right? That is my remainder, and that 1 is your quotient, right? Okay, now in long division method, how we can write down the polynomial? So we can write down the polynomial p of x equals divisor into quotient plus the remainder. Right. Okay. Now, when the polynomial, this was your polynomial, right? This polynomial is divided by your divisor. Then what happened? When the polynomial is divided by the divisor, it means d of x into q of x. This is also divided by the divisor, and the remainder is also divided by the divisor. So these terms are cancelled out. So we are left with when the polynomial is divided by your divisor, that is always equals to quotient plus remainder over the divisor. Right. Okay, let me write down this polynomial, this whole function basically. Okay. So here we can say x cube plus 2x. This whole function is basically x cube plus 2x minus 11 plus 2x minus 11 divides 3 plus x 2x plus 2 plus x square. 3 plus x into 2 plus x square. This is equals to, first write down the quotient. So what is a quotient in the long division method? 1 is your quotient, 1 plus the remainder. What is the remainder? Remainder is minus 3x square minus 17 minus 3x square minus 17 and divide by the divisor. This was my divisor, 3 plus x 2 plus x square. And here you can take a negative sign common from here, and you can put the negative sign here. Okay, now you can see you have converted the improper fraction to a proper fraction. Now the improper is converted into a proper fraction. You can see the denominator is 3. The degree of the denominator is 3 and the degree of the numerator is 2. So now this is a proper fraction. Now we can apply a partial fraction on this proper fraction, on basically on the left side. We can apply the partial fraction, right? Okay. Now apply partial fraction. Okay, so now this was your improper fraction. You converted the improper fraction to a proper fraction. Now we have to apply the partial fraction on the left side. This is a constant, leave it, just apply the partial fraction on these term. Okay, and then at the end we can substitute into this equation. We can name as equation 1. Okay, 3x square plus 17, you have a plus sign, sorry, divides x plus 3 into x square plus 2. You can write 3 plus x or x plus 3, both are same, right? Okay, now here you can see this is a linear factor, so you can write this down, a over that factor. This is a quadratic factor. Now you can write this down as bx plus c over that factor, x square plus 2. Okay, and let me name this as equation 2. Okay, multiplying both sides by x plus 3 into x square plus 2. So when I multiply this side by x plus 3 and x square, both are cancelled out. Just x square plus 17 is left, and that is equals to, when x plus 3 and x plus 3 is cancelled out, a is with product with x square plus 2. Okay, x square plus 2 cancel out with x plus 2, just this factor is left, bx plus c, and its product with x plus 3. Okay, now let me simplify. X 3x square plus 17, that is equals to a with x square plus 2 times with a plus bx x square, bx times 3, 3bx, c times x, and c times 3 means 3c. 3c. Bx square, 3bx, and cx and 3c. Okay. Now here we can let x plus 3. Now we have a linear factor x plus 3. We need to put it equals to 0, and we got the x value which is negative 3, and substitute that x value negative 3 and solve for one variable. Okay. Now when we substitute negative 3, we have 3 into negative 3 whole square plus 17 is equals to a into negative 3 whole square plus 2 times of a plus b into negative 3 whole square plus 3b x is negative 3 plus c x is negative 3 plus 3c. Negative 3 square is 9, and 9 times 3 is 27. In 27 we add 17, and here we have 9a plus 2a positive 9b and negative 9b, negative 3c and positive 3c. So here we can say 3 c's and b's both are cancelled out. Positive 9b, negative 9b, positive 3c, negative 3c both are cancelled out, right? Okay. Now simplify 27, add 17, which is 44. So here we have 44, and here 9 plus 2 is 11a, and 44 divided by 11, my a value, which is 11 times 4 is 44, and from here we got a is equals to 4. So we have done with a. Okay. Okay, now for to get b and c, as we have only one linear factor, so whenever you have a linear factor, as much as you have linear factors, you can have to put them equal to 0, and solve for x, and then substitute that x value into your equation and simplify the unknowns, right? Now in this case we have only one linear factor, which is x plus 3, so I substitute x plus 3 equals to 0, and I solve the a value. I got the a value. Now plug that a value, we can name it as equation number 3. Okay, so we can say put a is equals to 4 in equation 3. Okay, so when I substitute a equals to 4 in my equation number 3, it becomes 3x square plus 17, that is equals to 4x square, and 2 times 4 is 8, plus, because 2 times of 4 is 8, bx square plus 3bx, bx square plus 3bx, and then we have cx plus 3c, cx plus 3c. Okay, so now we got this equation. Now since there is only one linear factor, so we have to substitute that linear factor equals to 0 and solve for x, and substitute that x value into the equation, and we got one unknown. Okay, now there is no other linear factor. We have a quadratic factor, which is x square plus 2. We are not supposed to put it equals to 0. We have to compare the coefficients. So here we can say comparing coefficients of x square, x and the constant. First compare the coefficients of x square. Okay. Okay, let's compare the coefficients of x square. Okay, what are the coefficients of x square? X square coefficient is 3 over here. X square coefficient is 4. We have b. That's it. Now we got the b value. So 3 take away 4, which is equals to minus 1, is my b. So from here we got b is equals to negative 1. Okay. Now in the next case, let's compare the coefficients for x. X, yeah. Okay, so comparing the coefficients of x. So x, there is no x term, 0 here. X term is 3 times b and plus c. Okay, from here you will get the C value, right? Let me solve for C. So here C should be equals to minus 3 times B, since B is minus 1. So this is equals to, uh, oh, wait. C is as it is, just shift the 3B on the other side, negative 3B. C is equals to negative 3, B is minus 1. So here you will get C value equals to 3, positive 3, right? So C is positive 3, B value is negative 1, and the A value is 4, right? Now let me substitute all the values into your equation number 2, right? Put A, B, C in equation 2. We can say put A, B, C values in equation 2. Okay, now my equation 2 becomes 3x square plus 17. 3x square plus 17 divides x plus 3 into x square plus 2. This is equals to a over x plus 3. A is 4. So we can say 4 over x plus 3 plus bx plus c over the second factor, right? Bx plus c. B is minus 1, minus 1 times x plus 3, minus x plus 3 over the second quadratic factor. This. Okay. So this is my second equation. Now substitute that second equation into your equation number 1, right? Okay, so here we can say put above expression in equation 1. So what was my equation? The final one. Okay. Now this equation over here, right? X cube plus 2x minus 11. X cube plus 2x minus 11 divides 3 plus x, 2 plus x square, that is equals to 1 minus this whole thing. 1 minus and this expression, right? Okay, so it means we have negative 4 over x plus 3 and negative 3 minus x over x square plus 2. Or if we simplify this expression, you will get x cube plus 2x minus 11 divides 3 plus x into 2 plus x square. This expression is 1 minus 4 over x plus 3. And if you take minus common as it is, yeah. And then we have just absorb the negative sign inside. Negative times negative is positive x, and negative 3 over x square plus 2. Now this is how we have to write this expression um, in partial fraction. Okay, so we have to express f of x in partial fraction. So this is your function f of x. We expressed this function f of x in partial fraction. This is your function f of x. This f of x can be expressed in this form, right? Now for part B, hence obtain the expansion of f of x. We have to obtain the expansion of f of x in ascending powers of x, means the increasing powers of x up to and including the term in x square, means the x constant x and the x square term, right? So means the expand, we have to do the expansion of f of x. So here we have to do the binomial expansion. Binomial expansion. So the formula for the binomial expansion is 1 plus x to the power n is 1 plus nx plus n minus 1 divided by 2 factorial. x square. So we have to stop at x square. We need a constant x and the x square term because they're asking for till x square, right? So in binomial expansion, the first term should be 1 and the second is your x, the function of x, right? Okay, so this is your f of x. We have to expand this f of x. So we can write f of x as f of x is basically 1 minus 4 and x plus 3. So when you can shift x plus 3 to the numerator, becomes power minus 1 plus x minus 3, and we have x square plus 2, its power is minus 1. Now here we have to expand this function f of x by applying the binomial expansion. So basically we have to expand this, we have to expand this, but the first term should be your 1 and the second is your function of x, right? So let me rearrange. We have the function f of x is equals to 1 minus 4. So here we can divide by 3, right? So 3 by 3 plus x by 3 and its power is negative 1. Sorry, multiplying and dividing by 3. So before doing this, let me do one more step. This will make you confused. Okay. So I took 3 plus x power is negative 1 plus x minus 3, and then we have 2 plus x square, its power is negative 1. Now we can take f of x is equals to 1 is a constant minus 4. Now we can write this 3, make 3 as 1. So how do we make it as 1? We have to take 3 power minus 1 common, right? And here we have 1, 3 is divided by 3 and x by 3. So x by 3 and its whole power is negative 1 plus x minus 3 is as it is. Here we apply the binomial expansion, make this 2 as 1. So 2 power minus 1, take it common, and then 2 by 2 is 1 plus x square divided by 2 and its whole power is negative 1. Okay, now we apply the binomial expansion. We have f of x is equals to 1 minus 4, 3 power minus 1 divides by 3. Apply the binomial expansion, 1 plus x power n, 1 plus nx plus n minus 1 by 2 factorial into x square. Okay, so let me apply this binomial expansion. So we have 1 is as it is plus n times the x term plus n minus 1 divided by 2 factorial into x square, means x plus 3 whole square till x square term. This is your constant x and x square term, right? Now the second one is you have x minus 3 is as it is, divides 2 because 2 power minus 1 divided by 2. Apply the binomial expansion here as again 1 is as it is plus n times your x square divided by 2. So here I stopped at x square by 2 because I got the x square term, right? So I'm not doing the further because n minus 1 divided by 2 factorial x square. So x square by 2 whole square gives you x4 term. So that is why I'm stopping over here, right? Okay, so let me simplify this further. We have f of x is equals to 1 minus 4 over 3, and we have to put the bracket 1 minus x over 3. Okay, 1 minus minus 1 becomes minus 2. Minus 2 times minus 1 is 2, and 2 by 2 is just 1. So we have just x square over 9 plus x minus 3 divided by 2 bracket 1 minus x square over 2. Okay, let me simplify this further. We have f of x becomes 1 minus 4 over 3. Now split 4 by 3 inside, right? 4 by 3 times by 1, 4 by 3, minus times minus gives you plus. 4 times x, 3 times 3, 4x, 3 times 3 is 9. This becomes minus, sorry, negative times positive is negative. 4 times x square is 4x square. 3 times 9 is 27, plus this whole thing product with 1, so x minus 3 divided by 2, and then minus x minus 3 divided by 2, its product with x square by 2. Let me simplify the last step. Okay, f of x becomes 1 minus 4 by 3 plus 4x over 9 minus 4x square divides 27 plus x over 2 minus 3 by 2. So I split this, right? Okay, so this is minus 1 by 4. Okay, and x square with the x would be x cube and minus 3 times x square. We don't need x cube term, right? So you no need to write it down. And then we have to simplify 4 over 9x minus 4 over 27 with x square plus 1 by 2 with x minus 3 by 2. Okay, so now minus 1 by 4 with x cube. I'm not going to write down x cube. Minus 1 by 4 times by minus 3 becomes positive 3 by 4 x square, because we need the expansion till x square, not the x cube, right? That is why I'm not writing down the x cube term, right? Okay, now let me simplify the constant x and the x square terms, right? So now we have f of x, the constant terms are 1 minus 4 by 3 and minus 3 by 2. This is my constant, plus the x terms are 4 by 9 is the x term, plus 1 by 2 is the x term. Okay, plus x square terms are minus 4 over 27 and plus 3 by 4. These are the x square terms. Okay, let me simplify. We have f of x is equals to, let me solve with the calculator, what is 1 minus 4 by 3, and then we have a minus 3 by 2, minus 11 over 6, negative 11 over 6. Okay, 4 by 9 and 1 by 2, 4 by 9, and then we add 1 by 2, 17 over 18, 17 by 18x, and the last term, the x square term, is negative 4 over 27 and then positive 3 by 4. 65 over 108. 65 divide 108 is a coefficient of x square. So this is how we do the expansion of the function f of x till up to and include the term x square. All right. The ascending powers of x including the term x square. So this is how we do the expansion. Question number 11. With respect to the origin O, the points A, B, C, and D have position vectors given by OA, OB, OC, and OD. The line M passes through the points A and B. So there is a line M which passes through the points A and B, this point A or this point B. Part A, find the vector equation of line M. Okay, so the vector equation of a line is has an equation R is equals to A plus T times B. P or TB we can say. T times V we can say. Okay, now what A is? This is the vector equation of a line. So we need to figure out the vector equation of a line M which passes through the point A and the point B. So there is a point A and some point B, a line which passes through 2 points. We need to figure out the vector equation of that line. Okay, so vector equation of a line has a formula R is equals to A plus TV, right? So what A is, so here we can say A is passing point So the line passes through the point A or B, so you can take A as a point A or a point B, right? So this A, and V is the direction vector of line direction vector of this line, right? So the direction vector can be, because the line M passes through the point AB, so A is your any passing point. You can take a point A as a passing point or a point B as a passing point, and V is the direction vector. So what direction vector is? The direction of this line means AB or BA. This is up to you. You can calculate any one of it. Okay, so here we can say, first figure out the direction vector. Okay, so the direction vector, you can do AB or BA, direction of the line. So let me do BA. You can do AB as well, both are correct. So BA is basically OA minus OB, second minus first, right? So what OA is? OA is 153, 153 minus OB is 041, 041. Okay, so this is equals to 1 minus 0, 5 minus 4, and 3 minus 1. So this becomes 1 minus 0 is 1, from 5 take away 4 is 1, from 3 take away 1 is 2, 1, 1, 2. This is the direction vector. So we need to put the direction vector over here. V, and A is a passing point. You can take a point A or point B. This is up to you, right? So here we can say the vector vector equation of line M R is equals to the passing point. I can take passing point A 153. You can take B as well, 153 plus T times the velocity vector. Sorry, the direction vector 112. This is a direction vector 112. Okay, so you can take the passing point B as well. So here you can put the passing point B, and you can take the direction vector AB as well. You will get the same answers, right? So this is how you have to calculate the direction vector equation of a line. So vector equation of a line, we need the passing point, any passing point, plus T times the direction vector. Direction vector is basically the direction vector is parallel to this line, whether A, B or B, A, because this line passes through these 2 points. That is why I'm taking A, B or B, A, right? Now for part B, find the position vector of the point of intersection of M and the line passes through the point CD. Okay, so we need to find the point of intersection of the line M and the point of intersection of the line that passes through the point CD. As we have done that, the equation, this is a vector equation of the line that passes through the point AB. Now we need to figure out the vector equation of the line that passes through the point CD. Okay, so here we can say the vector equation of line passing through C and D. Okay, so let's say there is a line which passes through the point C and the point D. Okay, so what is it? Vector equation. Vector equation is again R is equals to A plus, we already used T, we can use lambda times V. A is the passing point and V is the direction vector, right? So you can take passing point as C or as D. C is 1 minus 3 and 1. Okay, let me write C, which is 1 minus 3 and 1. And what is the point D? D is 3 minus 5 and 4. Okay, 3 minus 5 and 4. This is the point D. Okay, now for the vector equation of the line that passes through the point CD, we need the passing point. You can take a passing point as C or as D, this is up to you, and the direction vector of the line which is parallel to the direction vector, basically CD or DC. This is up to you, right? So first let me solve for the direction vector. Direction vector is V. We can do CD, which is OD minus OC. Okay, so this is 3 minus 5, 4, and you do a subtraction with 1 minus 3 and 1. So 3 minus 1 minus 5, negative times negative is positive 3, and 4 minus 1. So here we have 2 and minus 2 and 3. This is the direction vector. Okay, so here we can say the vector equation of the line which passes through the point CD. We can take a passing point. I'm taking a passing point C, 1 minus 3 and 1. 1 minus 3, 1 plus some scalar lambda times the direction vector, which is 2 minus 2 and 3. Now we have the vector equation of the line which passes through the point AB and the vector equation of the line which is passes through the point CD. Now we have both vector equations, right? Now we need to find their position vector of point of intersection. Position vector of point of intersection, right? It mean, what does it mean? It means that, let's say there is a line which passes through the point AB. Let's say the point A, B and A, and there is another line which passes through the point C and D, and they have a point of intersection. So we need to figure out the position vector for this intersecting point. Okay, so for this we need to put both of them equal to find the position vector of point of intersection, right? So here we can say the position vector of point of intersection of two lines. Okay, now we have to put both the lines equal, 1 5 3. Okay, so here 1 5 3 plus t times 1 1 2 1 1 2, yes, 1 1 2 is, this would be equals to 1 minus 3 1 plus lambda times, we are not taking t over here because both would be same, so we have to solve for t and lambda. Okay, so here you will get the equation 1 plus 1 times t, 5 plus 1 times t, 3 plus 2 times of t, that is equals to 1 plus lambda 2 lambda minus 3 minus 2 lambda and 1 minus 1 plus 3 lambda. Okay, now here we have the equation 1 plus t is equals to 1 plus 2 lambda. You will get the first equation, and from here 1 is cancelled with 1. T is basically equals to 2 times of lambda. That is my first equation. And the second equation is 5 plus t is equals to minus 3 minus 2 lambda. So substitute the value of t, which is 2 lambda. So 5 plus 2 lambda is equals to minus 3 minus 2 lambda. Combine the lambdas, 2 lambda is already here, shift this on the other side, plus 2 lambda is equals to minus 3, and shift the 5 on the other side, minus 5. So this is 4 lambda is equals to negative 8, and lambda equals to negative 8 divided by 4, and 4 times 2 is 8. From here you will get lambda is equals to negative 2. We got the solution for lambda. So once we have lambda, we can put it back and solve for t. So from here, what is t? t is equals to 2 times lambda. So t is equals to 2 times of negative 2. So t is equals to 2 times minus 2, which is equals to negative 4. So we have t and we have lambda. All right, now we have t and lambda. Now we can easily figure out their point of intersection, the 3 points of intersection basically. Okay, so you can put 1 plus t, 5 plus t, 3 plus 2t, or you can put the values in this equation, right? So position vector of points of intersection, position vector of point of intersection of two lines, that position vector is, we can put in this or you can put in this, both are same. 1 plus t, 5 plus t, 3 plus 2t. T is minus 4, right? 1 plus t, 5 plus t, t is 4, and 3 plus 2t, 3 plus 2 times of t, that is equals to negative 3, negative 1, sorry, positive 1, not negative 1, and 3, 3 plus 2 times 4 is 8, minus 8 plus 3 is minus 5. This, or you can do on the second one by putting the value of lambda. 1 plus 2 lambda, what is lambda? Negative 2. And you can do minus 3 minus 2 lambda, minus 2 lambda, or the third one, 1 plus 3 lambda, 1 plus 3 times of lambda, lambda is negative 2. Let me check on this. 1 minus 4 minus 3 and plus 4, 1 minus 6, and you will get the same, minus 3, 1 minus 5. So you have the same vector equation of point of intersection, whether you substitute over here or over here, right? So this is basically the vector equation for the point of intersection. Now for part C, find the position vector of the foot of the perpendicular from C to M. Okay, so what M is? As we know that M is the line which passes through the point AB. Let's say this is a line M which passes through the point A and the point B. Let's say this is a point, there is a point C over here, right? Perpendicular from C to M, from C to M, perpendicular foot. So this point is your foot. We have to label it as F, right? We need to figure out the position vector of this point, OF, right? All right. So as we have done the vector equation of the line AB, so in part A, vector equation of the line M, R is equals to, what is that line? 1 minus 3, yeah, 153 plus t times 112. 153 plus t times 112. So this is the vector equation of the line M which passes through the point AB. So we have to take a passing point, whether A or B, and we need the direction vector AB or BA, right? Now as we know that the point F lies on the line M, right? So since the point F lies on line M. So the position vector of F is same as the vector equation of M, because this point F lies on this line M. So the position vector of F and the vector equation of line M both are same. So the position vector of F, we can say OF should be equals to 1 plus 1 times T, 5 plus 1 times T, 3 plus 2 times T. This should be your position vector of F, foot. So we have to solve for t and then just plug into your first equation. Let me name this as equation number 1, right? Now we have to use the concept of perpendicular. Now two lines are perpendicular. When two lines are perpendicular, we have to take the concept of gradients or the slopes of those lines. But in vector, um, uh, we have to use we can say the gradient is basically the direction vector, right? So, since two lines are perpendicular, it means the direction vector of CF and the direction vector of AB. We have to take the gradient of CF and the gradient of AB because two lines are perpendicular. But in terms of vectors, we are not saying gradient, we have to say the direction vector. Okay, so let me take the direction vector. Direction vector CF, which is OF minus OC, second minus first. So OF is 1 plus T, 5 plus T, 3 plus 2T minus OC. Okay, so the point C, 1 minus 3 and 1. 1 minus 3, 1. That is 1 plus T minus 1. Let me do it over here. 1 plus T minus 1. 5 plus T, negative, negative, positive 3. And 3 plus 2T and minus 1. What is its direction vector? So the direction vector CF, this should be negative, negative is positive, cancel out T, 8 plus T, and we can say 2 plus 2T, because 3 take away 1 is 2, right? This is a direction vector CF, and we have done the direction vector AB or BA in part A. Direction vector BA 1, 1, 2. And we have done BA, which is 1, 1, and 2. Okay. Since the two lines are perpendicular, so we can say when two lines are perpendicular, their direction vectors, when two lines are perpendicular, product of their direction vectors, dot product of their direction vectors equals to 0. Dot product of direction vectors equals to 0. So when you are doing in the real world, we can say when two lines are perpendicular, the product of their gradients equals to -1. And when in vector terminology, when two lines are perpendicular in vectors, the dot product of their direction vector is equals to 0. Okay, so what does this means? It means the dot product of CF and the dot product of BA, that should be equals to 0. Okay, so let me put this equals to 0, 8 plus t, 2 plus 2t. T 8 plus t, 2 plus 2t, the direction vector of the first line, dot product with the direction vector of the second line, that should be equals to 0, right? So in the dot product, how do we solve the dot product a dot b? So we can say product of x component, product of y component, product of z component, and sum them up, right? So the x component product is t into 1 plus the y component is 8 plus t into 1 plus the z component is 2 into 2 plus 2t, that is equals to 0. So this is t plus 8 plus t, 2 times 2 4 plus 2 times 2 4t equals to 0. Now 4 5 6, this is 6t, and 8 plus 4 is 12 is equals to 0. So now 6t is equals to negative 12, and t is equals to minus 12 divided by 6. 6 times 2 is 12. So from here the t value is negative 2. Now plug this t value into your equation 1. Put t is equals to negative 2 in equation 1, and you will get the position vector of f. Position vector OF, that is equals to 1 plus t, 5 plus t, 3 plus 2t. 1 plus t, 5 plus t, 3 plus 2t. So just substitute the t value, which is negative 2, 1 minus 2, 5 minus 2, 3 plus 2 times minus 2. That is equals to 1 minus 2 is minus 1, 5 take away 2 is 3, and 2 times 2 4, negative 4, and positive 3 is negative 1. So this is a position vector, we can say OF. All right. So in this question, we have to use the concept that we have a line M passing through the point AB, and there is a point C perpendicular from C to M. This point is your F. We need to figure out its position vector, right? So we have already done the velocity vector equation of line M, and we come to know from this diagram that the point F lies on this line M. It means the position vector of F must be equals to the vector equation of line M. So you will get OF, right? Okay, so to get OF, solve for OF, we need T, right? Okay, now we use the concept of perpendicular. When two lines are perpendicular, we use the concept of their gradients, right? So in vectors, we can say gradient as direction vector. Yeah. So it means the direction vector CF and the direction vector of the line M, their dot product must be equals to 0, right? We put the dot product equals to 0, solve for t, and substitute that t into a OF, and we got the position vector OF. All right, so that was the last question of our paper. If you have any queries, please let me know in the comment section, and please subscribe to my channel. Thank you for watching. See you next time. Take care.